All right, we are in chapter 5, developing a training foundation, and this is step 5 covered in the book. When you're developing a training foundation, you want to learn the 15 laws of training. These are made up, they're contrived, but they cover some pretty good ground and good things to follow. Remember, the goal of a training program is to be as fit as possible when you hit that start line with the least amount of injury present. Hopefully, you're injury free when you're at that start line. That's going to give you your best chance to be successful. Sometimes you need to sacrifice your training response to minimize the risk of injury. And sometimes you take a little bit of risk and see how far you can push yourself to improve your fitness. But now you're running the risk of having an injury. So it's this constant battle and balance of getting your training, your physiological training response, as well as minimizing risk of injury. Okay, learn the 15 laws of training. Remember, runners get injured. The point of these laws is to increase performance while decreasing the risk of injury. Performance can be thought of as achieving the desired goal: weight loss, 5K time, completing a marathon, what have you. Again, going back to the goals, if I'm trying to help someone get to a sub 21-minute 5K, the training program is going to be a little different than if I'm just trying to train someone to lose 10 pounds and their time of the 5K is not important. So we have to remember that, and we need to build the training program appropriate to that. And remember, we're dealing with mere mortals versus elite athletes. Although the laws still apply to elite athletes, they just may require a little special more attention to sort of tweak that program specific to them. You want to watch out for pitfalls, excessive training, sticking to schedule, and we'll go through some of those pitfalls as we do this chapter. Let's see, 1922 and 1935, Englishman Arthur Newton developed the 9 initial aspects of training. Okay, so some of the initial ways of thinking about training for an endurance event, and then Noakes adds some additional laws, which sort of complement those previous ones. And again, these are contrived. And if you pull 10 coaches together, their laws are going to be a little bit different, but the concepts will likely all be very similar. All right, law 1, train frequently all year round. This is something I really talk with athletes about who are age group athletes competing for endurance events, is they should have above and foremost consistent training. Consistent week in, week out for a period of time. To do consistent training, you need to have the right level of intensity planned out. You cannot have high intensity training so frequently that it causes you to miss exercise sessions. And this is something to keep in mind, especially as athletes get older, is the amount of intense exercise they can tolerate is going to change. And you need to adapt to that when you're working with an older athlete, because the most important thing is generally consistent training. The body adapts to stress. Too much stress, however, leads to injury, and too much stress would be analogous to too much intensity. And we do have too much volume, and that's an issue too. We need to deal with that. You can reduce stress, especially for running, by doing cross training, deep water running, or Alter G, body weight support running. Or in the case of triathlon, you cross train naturally because you're swimming, biking, and running. Uh, a lot of people will actually benefit from including walking during training, especially for long distances. And there's some different strategies to incorporate walking. And we call these a run walk program. They're, especially when you start dealing with long distance events, a marathon or longer, there is some benefit to planning walks within periods of running. And there's different training programs to help introduce that. Now, elite level training cannot even be sustained year round, and elite athletes do take time off to recover both the body and mentally. Uh, Sometimes it's rest completely for 2 months. Now, that's not just sitting on the couch for 2 months, but it may be really low levels of exercise real small stimuluses to the person. Or it may be, doing a different sport entirely for 2 or 3 months at a time. Maybe switching over to mountain biking instead of road biking, or maybe doing some hiking instead of running. But to train year round at a high level is really challenging. Even the professional athletes will take some time off. So the training response is all predicated on what's known as the general adaptation syndrome by Hans Saleh. This is really the basis for a training program. And what we have here is, on this plot, is resistance to stress and time. Resistance to stress on the y-axis and time on the x-axis. And that red line or red arrow representing introduction to some stress. The bottom line with this model is that this describes how an organism will respond to a stress. Okay, the stress for us right now is an exercise session. Ultimately, if done correctly, the body will adapt to the stress. But if the stress is too much, either one time or over a long period of time, you can get an injury. So when you have a stress, this red arrow, the body responds through an alarm. That's the phase that's referred to in the Saleh's model. Uh, and then you will have resistance and you have adaptation. But if you continue to apply the stress, you will ultimately get injured. And so you do need that adaptation phase to resist the stress. So the alarm is also known as the fight or flight phase. You have an increased heart rate in terms of exercise, increase of release of adrenaline. Then you have some resistance that builds up, the adaptation. You need a repair phase, you need recovery, and there are some hormonal issues that happen during this phase, bringing heart rate and blood pressure back to normal. And ideally, the body learns to adapt to the stress. The body learns to adapt to the exercise intensity. That's the whole goal of a training program, is to train the body to respond to the stimulus of stress of exercise. Now, exhaustion is when the stress is applied too long um, or too frequently, and the body has not had time to adapt to that stress. And when you have that, then you ultimately have an injury. All right, so that's the adaptation syndrome, and that's the whole goal of a training program, is to train the body to resist or to adapt to the stress that's imposed to it during training. So different levels of running. All right, law 2, start gradually and train gently. Yes, start gradually. Too much change too soon will lead to an injury. And that change could be a change in running surface, could be a change in shoes, it could be a change in volume, intensity, frequency, or time. Too big of a change, the body will not have had time to adapt. And so recovery becomes really important, and making sure that you're choosing the right level of intensity to allow the body to respond positively is important. Novice runners should probably run longer distances at a comfortable pace rather than incorporating some high intensity. Now, there is a lot of value to high intensity training, but you got to monitor that because that's a stress. And if you don't adapt to that stress, you're going to lead to an injury. So you do need to have that foundation of training before you really jump into a high intensity training. Borg scale of rating perceived exertion, RPE scale, that is really an important scale so that two people can talk to each other and share their experience or their level of perception of effort. That's really all it's built on, is so that I, as a researcher, can talk with a subject in terms of how hard they are perceiving the exercise intensity. You can use a heart rate monitor that gives you a little bit more objective measure of intensity, and we'll talk about that in just a little bit. You can have some misleading information, or you can use it incorrectly if you don't have enough knowledge about heart rate. So here's Borg scale, and this is a really good way to communicate between people. We use this all the time during stress tests to ask the subject or the patient when working in cardiac rehab how hard they feel the exercise is. And as they progress in an exercise test, they move towards that 20 number. And now the scale's been modified to be, up to 10 point, so a 10-point scale. But as the intensity increases, their perception of intensity increases. And that's a good, message to have in terms of talking with people about intensity. Now, RPE is directly related to heart rate. And this scale, the reason why we've have gone to a 10-point scale is because this scale was built off of 20-year-olds on average. And so maximum heart rate for a 20-year-old would be 220 minus 20, which would be 200. So this 20-point scale is really built on the idea of how a 20-year-old would respond in terms of heart rate. You would just multiply their RPE number by 10. So just a little bit of history there with RPE. Okay, so intensity, I really need to understand the Fick equation. Rate of oxygen consumption, VO2, is equal to the product of heart rate, how fast the heart is beating, times stroke volume, how much blood is pumped with each beat, times the AVO2 difference, or how much oxygen is extracted from the arterial blood and then returned to the venous blood. The product of those three things will tell you VO2. It's really hard to measure stroke volume. It's really hard to measure AVO2 difference. It's really easy to measure heart rate. The nice thing about these three parameters is they change very predictably with intensity of exercise. So here's just some easy plots. Here's VO2 on the x-axis for each of these plots. Lower, higher VO2 means higher intensity. A greater rate of oxygen consumption means a higher intensity of exercise. AVO2 changes pretty predictably with increases in intensity. Stroke volume increases a little bit at first, and then it tends to plateau as intensities get higher. And heart rate continues to increase relatively linearly as VO2 increases. Heart rate increases at this linear rate because of the way these parameters change. This is an easy or good predictor of VO2. And so in the field or running outside or biking outside, if I measure heart rate, I'm going to get a pretty good indicator of what VO2 is, as long as stroke volume and AVO2 difference change predictably with intensity. If these do not change predictably, then my understanding of heart rate as it explains VO2 goes away. And I run into some problems. So we need to keep that in mind. So if I'm dehydrated, my stroke volume may change, okay, as an easy example. So if the stroke volume changes, then my heart rate has a different meaning for a given VO2. If the amount of oxygen in the air, like doing, hiking up in Charleston, if the percentage of, if the density of air is going to change, then we're going to have the ability to get less oxygen into the arteries, which means I may have a less of an opportunity to get oxygen out of the arteries, which then means my heart rate is going to have a different meaning, okay, when I'm exercising at altitude. So keep that in mind, that VO2 is a function of these three things, but we typically only measure one, and we measure one because these other two are relatively predictable in general during steady state submax exercise. Now, once we have that understanding, we can start using heart rate to develop these different zones. And the different zones are then also predicated based upon where a lactate threshold would occur, or lactate turn point would occur. And the importance of lactate turn point, lactate threshold, is that's an intensity of exercise that if we go above that, we're probably starting to use more anaerobic production of ATP. Depending on what you're doing for your training program, you may want that or you may not. If developing a training foundation, you want to stay below that lactate threshold, that anaerobic threshold. And you really want to do primarily exercise down in these zones down here, weight management and healthy heart zone. There's different zones based upon which which routine or which guidelines you follow, but this is a 5-zone model here. So monitor heart rate during exercise, develop your own guidelines, because it is important to know how your heart rate responds. And here's just some data from wearing wearable technology. This is heart rate, and this is distance during a 26.2 mile run. So this is a marathon. And this is another set of data from heart rate over a 6.2 mile run, so 10K. This is a 10K and this is a marathon. Notice this heart rate is changing over time, and you see these breaks or these drops in heart rate. This person's following a run-walk program. They're running, then they're walking. They're running, then walking, running, walk. And the heart rate is coming down for each walk that they do. That was a strategy this person employed in order to cover that 26.2 miles consistently and successfully. In a 10K run, this person's heart rate continues to go up and up and up and up and up, all right? Which is not atypical. Your intensity of exercise, this person, if I put pace here, maybe they're running faster and faster and faster throughout the 10K. And so heart rate is changing. And so it is good to have a sense of how your heart rate changes, and there's lots of good devices to be able to measure that. Law 3, train first for distance and then later for speed. So this stays with that same idea of building a good foundation. And it's held up over the years. And, doing the high intensity training, that can really help, but you really need a good foundation to sort of work off of that. The challenge, again, is matching up individual goals, ability, schedule to develop a training program. If you have no desire to improve your 5K time, then you do not need to do 5K race pace type of work. Some training programs focus on time spent versus distance covered, and that's good to know, is that someone may be prescribing to run an hour or an hour and a half versus trying to run 8 miles or maybe 10 miles. And sometimes spending the effort on time is more important than trying to cover a particular distance. Law 4, don't set your daily training schedule in stone. You do need to be flexible. Life does happen. If you have kids, your kids wake up and they're sick, and you got to deal with that, or maybe you got to change in schedule because of a presentation, or maybe something's going on in the family or work that you need to adjust. And that's really important to be able to be flexible in your training schedule. Now, it is important to have a regular training schedule, but at the same time, you don't want to get to a point where you're sacrificing family, you're sacrificing work and career in order to fit that run in. Daily training should be a guideline, be flexible, monitor how the legs feel in terms of the training response. You do want to be careful about getting overly sore and stiff, and you don't want to have to abandon a run during a run. You really want to make a decision prior to exercise that they're set. And if you're getting to a point where you don't feel like you can continue your training program, then you're not doing the right amount of intensity, or doing too much, or doing too long, doing too frequently. Sometimes it helps to get a coach. Oh, I got 50 to 60-minute run. Really, don't get hung up on some of the details. You don't need to log 52.5 minutes of running. Ballpark numbers can sometimes be good. Again, depending on the goal that you're shooting for. Some people may want to get a coach. What's nice about a coach is that person can be objective about your training program. They can look at the data, they can talk with you, and they can make adjustments as needed. I do not, when someone says that they're starting, I typically don't push them towards a coach. I mostly want to see them get started with training and work it in their regular schedule, and then get a coach to make sure that they can get the best benefit out of the coach. And when they are looking at coaches, I tell them to interview the coaches, make sure that what the coach has to offer matches what they want. And again, if you're dealing with someone who wants to lose weight, you got to have the right coach. You don't want a coach who's trying to train competitive athletes if you're just trying to lose weight, or vice versa. Don't try to replicate elite or professional athlete training programs unless you are an elite or a professional. Can you handle 20 hours per week? Can you run 100 miles per week? Professionals and elite athletes are doing that. You simply should not follow what the elite athletes are doing, because again, they're setting up their training program for a year, maybe even 2, or maybe even a 3-year program. And to know what they do in any particular week is really a misrepresentation of what they've done to even get to that period of time or period of their training program. So, it's always fun to see what elites are doing, but don't try to mimic it into your program. Law 5, alternate hard and easy training. This goes back to Hansaye's adaptation model. You need time to recover, stress, rest, recover, let the body adapt. Bill Bowerman and Bill Dellinger observed that their athletes progressed best when they are allowed 24 to 48 hours of recovery after intense training sessions. Anecdotal information, but it's important. You need to have that recovery before and after doing high intensity training sessions. If the previous training sessions were strenuous, adequate recovery time must be allowed. You got to restock glycogen, you got to repair micro damage, muscle, bone, what have you. You need that recovery. And there's a lot of neat science now on the importance of recovery during endurance training programs. Law 6, achieve as much as possible on a minimum amount of training. I mean, that's really, the trick is getting to where you can optimize your training time to maximize your performance. But this is hard. This is determining your training load. It's tricky, but it is simply a manipulation of frequency, intensity, time, and mode of exercise. Mode being swim, bike, run, hiking, whatever it is, ends up being strength training. This is just a graph of a training program over a period of time, just from May 4th to August 24th, and just looking and quantifying the amount of stress that someone has during this training program. And you can see the long-term stress is increasing consistently, and that makes sense if you're doing a training program. And then there's different cycles in this training program to increase intensity, but then recover, increase intensity, and then recover. And ultimately, you'll get a long-term benefit of that. Training volume versus race performance. You do want to optimize training program. You want to avoid injury. You want to minimize the risk of injury. And the thing to remember is some people really just enjoy training, and performance is not important, right? In some times of the year, you reach what's called an off season, even if you're not an elite athlete. You may, as an age grouper, say, "Oh, this is my off season." That's the time to really take a step back and make sure that the person is enjoying the training, enjoying the process, because that is the key to long-term success. First victory, I've said this a few times, get to the start line injury-free. Second victory, get to the finish with your performance goals in mind, and that would be having your best fitness when you get to the race. So this is just race performance here, amount of training, and then different, this idea of at some point you're going to get the amount of training stress where there's just diminishing returns. You're just doing too much. And maybe you even get to a point where you're overtraining. You're doing so much stimulus that you don't have time to adapt, and your race and performance is not improving. Maybe initially you get these big gains in improvement, and then you maybe get a little bit more gains improvement, not so much. But then at some point you just say, it's just not worth it to add another session of running, because you're going to increase your risk of an injury, and you're better off doing something else. Law 7, don't race when in training or run a race pace at distances above 16 kilometers, which is about 10 miles. You want to be careful about how much intensity you have in your training program. And this law is really predicated on doing a long-term training program. And you want to be careful about how many high intensity race situations you have in a training program, because you need to be able to adapt and recover to that. And sometimes after a true race effort, you need some time off that could interfere with your long-term plans. Now, what some athletes do is they create what they call A races, their most important race, B race. That's sort of important, not that important. and then C races, which often are just, okay, well, I'm going to do this race and maybe I'm going to try some different things on my race strategy, maybe try a different pair of shoes or a different pacing strategy or different fuel, and the performance is not as important. Here, what Noakes is talking about is high intensity, highly competitive races. You really want to pick those very sparingly and really plan for those. So for marathon runners, 6 to 8 weeks should occur between events. Noakes recommends all novice runners to initially avoid time trials and to focus on building endurance, not speed. Hopefully you've heard that. I heard me say this already. The shorter the race, the more frequently it can be performed, 5Ks, but still you need to pick those 5Ks that are really the key ones that you're shooting for. 1 or 2, maybe 3 races longer than 32K should be performed per year. And 21K is a half marathon. So you're talking 18-ish miles at that point. So, all right, the longer the event, the less frequently you can do it. Law 8, specialize. Law of specificity. If you want to be a good runner, you got to run. To be a successful runner, 2 or 3 hours per day need to be set aside for training. This is, more towards the elite runner at this point. For a novice runner, you may need to do 20 minutes to an hour. Individuals who are conditioned only for the sport in which they're trained, this is specializing. Forms of specialized training include speed training, hot weather training, altitude acclimatization, what have you. Strength, cross training, strength training, plyometrics. The picture is not always so clear in the literature, but that often is confounded by the type of athlete that they're using in the experiment or the goals that people are shooting for. It part of contemporary thinking is a lot of the strength training and including plyometrics is a benefit to endurance performance, partly because it does introduce some muscles to contract in different ways. The risk of specialization is that you're going to do the same thing over and over and over again. And that risk that specialization could lead to an overuse injury. So this is sort of a funny law, but if you want to be a good runner, you do need to run. You just need to figure out how to minimize the risk of injury to running. And sometimes that minimization is to do some other things related to running, like strength training or plyometrics, or swimming, or running in the water, or hiking. And same thing if you want to be a good swimmer, you got to swim, or a good biker, you got to bike. Law 9, incorporate base training and sharpening. So this is just going back to planning the training program out throughout the entire year. And the whole Hans Selye adaptation model, you introduce a stress, you need time to recover. Base training is just that long, slow distance. You're just improving that foundation. You want to prevent overtraining, but you are also learning to run faster for those longer distances as you improve that foundation. 6 training before any sharpening training, 6 months of training prior to any like high intensity or race prep type training. This graph is a little complicated. Don't worry about the details of the graph. What this is highlighting, however, is how complex a training program can be, where you are trying to plan out your phases of base training, your phases of race preparation, and race specific training. And some training programs get really detailed, and you've got to just match your goals with the type of training program you're going to do. Some training programs can be super simple. Do 100 runs in 100 days. That can be a great training program for someone who's just trying to improve their general fitness, or maybe improve their 10K time if they're middle of the pack type racer. Law 10, prevent overtraining. You do not want to get overtrained. It's difficult to quantify overtraining. There is a sense of overreaching is what you often want to do in a training program, but you don't want to overreach so much and so frequently that you're going to get to an overtraining response. Overtraining, we could define it as an accumulation of training and or non-training stress. That's work, school, what have you, relationships, resulting in long-term decrement in performance and capacity with or without related physiological and psychological signs and symptoms. This is a real thing. And people can get overtrained, and that really does lead to a negative impact on their physiology and psychology. Restoration of performance may take several weeks or months if someone does truly reach an overtrained state. Now, you do want to do overreaching. You want short-term decrement in performance to ultimately allow for the adaptation. Adaptation does occur over time. This is just a sort of a model. You got a single training session on the left, and the amount of fatigue up top, and then training with inappropriate recovery, and increasing severity of overtraining symptoms will increase as we start reaching overreaching, and then maybe even overtraining. We have high levels of fatigue, inappropriate recovery is happening, and we have severe symptoms of decrement in physiology at that point. Okay, law 10, prevent overtraining, is to continue that. If you give a positive answer to 3 or more of the questions below, you may need to take some time to recover. Does your normally comfortable pace leave you breathless? Do your legs feel heavy longer and so forth? These are just general rules to follow for trying to figure out if you're overtraining. You can do also some physiological measures to see if you're getting to overtraining. The heart rate variability is a big contemporary marker to look at. But you really want to pay attention to this as you're going through your training program. Treating overtraining, true overtraining may take 6 to 12 weeks. I mean, that's 3 months of rest and recovery. Overreaching, maybe a day or 2 days, and then you start feeling better. That's overreaching, not so much overtraining at that point. Law 11, train with the coach. I mentioned this before. The coach can provide knowledge, objectivity, inspiration, accountability, and those can be good things. You got to pick the right coach. You got to interview coaches and make sure that that coach has the level of knowledge to help you achieve your goals. Or if you're the coach, make sure that you have the right knowledge and you are interviewing your athletes, so you're picking the right type of athlete. Law 12, train the mind. Mental toughness must be developed, cultivated, and cherished. And yes, the little engine that could. You've got to have that belief that you are able to handle some tough situations during endurance events. And this is trained, and you do need to prepare yourself for it. Law 13, rest before a big race. This is tapering. Now, it's not detraining. You want to watch out for detraining, but tapering, this is just a graphic over here on the left corner of different tapers of different objects. And you have lots of different ways to taper. And tapering is an art form, and you do need to figure out what does work, where you are sharpening your fitness and your race skills as you recover. And so this graph down here is just showing some stress over here, and there's just a triathlon, so different bike, run, and swim minutes, and it builds, and then tapers off. So then you have race week, and you're ready for your race. Law 14, keep a detailed logbook. This is easy now electronically. You can use electronic logbooks like Strava, Garmin Connect, or Training Peaks. These are all great ways to keep electronic log, but I still like a pen to paper type of log to be able to write things in as well. But it's good to have a record of what's happened so that you can go back if you get injured, or if maybe you've had a great race, you want to analyze what worked and what didn't. It can be really helpful to have the information building up to your event. Longevity, once you've started a program and understand laws of running, there is still lots of advice to consider to continue running for a long period of time. So keep that in mind, that you're always looking for more information and you want to enjoy it. Law 15, understand the holism of training. Everything affects how you run. So appropriate diet, amount of sleep, physical effort during the day, work stress, family stress, it all comes together, and it all influences your run program or your triathlon training program or whatever sport you're dealing with. And you do need to incorporate lots of different parts and account for that when you are building a training program. All right, that's where we are, Law 5. I'm going to stop there and pick up Law 6 on the next presentation. All right. Thanks, everybody.